So sorry to be gone second day this week. I have a doctor's appointment that was scheduled a while ago, and I did not plan clearly on being gone Tuesday because of the plumbing emergency. So, in any case, we're starting a new unit called Intro to Motion, and it's about distance and displacement today. So there's a couple of things we need to find first of all and get off our and make sure that we have a good solid understanding of them. First of all, vectors are defined as a quantity that has both magnitude and direction. But just to take a step back, quantity could be defined as a descriptor with value, and magnitude could be defined as the amount or number something has. The other thing that we need to talk about is something called scalars, and scalars are a quantity that has only magnitude. And I'm going to show you a couple of examples of what this might actually look like on the next slide. So vectors could be, vectors could be defined as something like going 50 feet to the right. The 50 feet is the magnitude and the right is the direction. So right would be this way. Whereas scalars would simply be something like 50 feet. Doesn't tell me much. Another option would be something like 3 miles north. So we have our magnitude and we have our direction, north. So north, east, west, south, south and west. So 3 miles north. Whereas a scalar value would be something like just 3 miles. Okay, so let's talk a little bit about mass, because that's another thing that we need to talk about. So mass is the amount of matter or stuff in an object. It's usually measured in grams or kilograms from last unit. So the question that we should ask ourselves is mass scalar or is it a vector? Well, in this case, mass would be considered scalar. Well, why? Well, it's scalar because just a mass has no direction. So an example of mass would be something like 5 kilograms of potatoes or 3 grams of paper clips. So that doesn't really tell me much other than just what mass is. Now weight, wait a minute, Mr. Postman, maybe, is the force of gravity pulling down on an object by the earth. Weight is usually measured in pounds. LBS is how we signify that. So then the question is it scalar or is it a vector? And in this case, I would say that weight happens to be a vector. Why? Is because it has because weight has magnitude and direction. Just in this case, the force of gravity is always pulling down. So an example would be something like, I happen to weigh 182 pounds. And the reason why I weigh that is because the force of gravity is pulling down. So that's why that's a vector. Speed is how fast an object is moving. So then it can be measured in like miles per hour, perhaps. But we have to ask ourselves again, is it scalar or is it a vector? And in this case, we are going to say that this is scalar. So why? Well, it's because it has magnitude, speed has magnitude, but no direction. So an example would be something like 35 miles per hour, which you now could convert to kilogram or meters per second if you wanted to. You don't have to. Good. Velocity is how fast an object is moving and in what direction. I don't know what's happening here. In what direction? So we should ask ourselves, is this a scalar quantity or is it a vector? Well, because it's giving us a magnitude and a direction, we're going to say that it's definitely a vector. So why? Because there is a magnitude or an amount and direction. So for example, we might have 45 miles per hour heading east. Okay? So now we need to define the ideas of distance and displacement. And distance is defined as the length, ooh, geez, spelling, the length of the path an object travels. Whereas displacement is the distance between the start and the endpoints. Oops. Displacement is the distance between the start and the endpoints after an object stops moving. So, for example, if I said this was my starting point and this was my end point, and I decided that I was going to travel 1 unit this way, and then eventually 1 unit this way, and then eventually 1 unit this way, I could say that my distance traveled is equal to 3 units. But if I said that I was going to travel, but if I was trying to decide the displacement that I actually moved, I'm going to check the distance between the start and the end. And in that case, the displacement is equal to 1 unit to the right. So distance is how far an object or a person actually travels, and displacement is how far away that object or person is from the start to the end point. And in this particular instance, it looks like I took the long way to get to the end, but the actual displacement was only 1 unit to the right. So there are some times when we are going to have to add vectors, and so vectors can be combined by addition. So the other thing is that vectors have magnitude, which is an amount, and direction, just to remind you. So I want to give you an example of how we could use vector addition. So for example, if I were to walk 2 meters north, so if this is me, and I walked 2 meters north, and then I turned around and I came back 1 meter south. 2 meters north, 1 meter south. Well, my displacement would simply be the actual distance that I ended up going from my start to my end. So my displacement would be the value of 2 meters north plus 1 meter south. So that would actually equal a grand displacement of 1 meter north. But the actual distance that I traveled would have been 2 meters north plus 1 meter south. And when you add that up, that actually equals a total of 3 meters traveled. Okay, so all we have to do is you have to decide if you're being asked to determine what the displacement is, that is the distance from the start point to the end point, or how far the object or the person has actually traveled, which is the total distance traveled. You're going to have an opportunity to practice that tonight with worksheet number 1, which probably shouldn't take you very long, and as a result of that, you should be able to have no homework over the weekend, and I will see you on Monday. Have a great weekend.